and alkaline earth metals differs in many respects from the other members of the group. As the S- orbital can accommodate only 2 electrons, 2 groups, 1 and 2, belong to the S- block of the periodic table. Group 1 of the periodic table consists of the elements lithium, sodium, potassium, rubidium, caesium and francium. They are collectively known as the alkali metals. These are so called because they form hydroxides on reaction with water which are strongly alkaline in nature. The elements of group 2 include beryllium, magnesium, calcium, strontium, barium and radium. These elements, with the exception of beryllium, are called the alkaline earth metals. These are so called because their oxides and hydroxides are alkaline in nature, and these metal oxides are found in the Earth's crust. Among the alkali metals, sodium and potassium are abundant, and lithium, rubidium and caesium have much lower abundances. 1. Francium is highly radioactive. Its longest-lived isotope 223 Francs has a half-life of only 21 minutes. Of the alkaline earth metals, calcium and magnesium rank 5th and 6th in abundance respectively in the Earth's crust. Strontium and barium have much lower abundances. Beryllium is rare and radium is the rarest of all, comprising only 10-10% of igneous rocks. Table 10.2. Page 299. The general electronic configuration of S-block elements is noble gas and S1 for alkali metals and noble gas and S2 for alkaline earth metals. The first elements of Group 1 and Group 2 respectively exhibit some properties which are different from those of the other members of the respective group. In these anomalous properties they resemble the second element of the following group. Thus, lithium shows similarities to magnesium and beryllium to aluminum in many of their properties. This type of diagonal similarity is commonly referred to as diagonal relationship in the periodic table. The diagonal relationship is due to the similarity in ionic sizes and /or charge/radius ratio of the elements. Monovalent sodium and potassium ions and divalent magnesium and calcium ions are found in large proportions in biological fluids. These ions perform important biological functions such as maintenance of ion balance and nerve impulse conduction. 10.1 Group 1 Elements. Alkali metals. The alkali metals show regular trends in their physical and chemical properties with the increasing atomic number. The atomic, physical and chemical properties of alkali metals are discussed below. 1st of October 1 Electronic configuration. All the alkali metals have one valence electron, Ns1, Table 10.1, outside the noble gas core. The held S-electron in the outermost valence shell of these elements makes them the most electropositive metals. They readily lose electron to give monovalent M+ ions. Hence they are never found in free state in nature. Number 2 Atomic and ionic radii. The alkali metal atoms have the largest sizes in a particular period of the periodic table. Atomic number, the atom becomes larger. The monovalent ions, M+, are smaller than the parent atom. The atomic and ionic radii of alkali metals increase on moving down the group, i.e., they increase in size while going from Li to Cs. 1st of October 3 Ionization enthalpy. The ionization enthalpies of the alkali metals are considerably low and decrease down the group from Li to Cs. This is because the effect of increasing size outweighs the increasing nuclear charge, and the outermost electron is very well screened from the nuclear charge. 1st of October 4 Hydration enthalpy. The hydration enthalpies of alkali metal ions decrease with increase in ionic sizes. Li plus greater than Na plus greater than K plus greater than Rb plus greater than Cs plus Li plus has maximum degree of hydration, and for this reason lithium salts are mostly hydrated. For example, Alkali Metal. 2H2O. 1st of October 5 Physical properties. All the alkali metals are silvery white, soft and light metals. Because of the large size, these elements have low density, which increases down the group from Li to Cs. However, potassium is lighter than sodium. The melting and buoyance of the alkali metals are low, indicating weak metallic bonding due to the presence of only a single valence electron in them. The alkali metals can therefore be detected by the respective flame tests and can be determined by flame photometry or atomic absorption spectroscopy. These elements, when irradiated with light, the light energy absorbed may be sufficient to make an atom lose electron. Physical properties of the alkali metals. Makes calcium and potassium useful as electrodes in photoelectric cells. 1st of October 6 Chemical properties. The alkali metals are highly reactive due to their large low ion enthalpy. The reactivity of these metals increases down the group. Reactivity towards air. The alkali metals tarnish in dry air due to the formation of their oxides, which in turn react with moisture to form hydroxides. They burn vigorously in oxygen-forming oxides. Lithium forms monoxide, sodium forms per, other metals form superoxides. The superoxide O2- is stable only in the presence of large cations such as K, Rb, Cs. 4-Leo oxide. Solution. The superoxide species is represented O2-, since therefore oxidation state of potassium is +1. Towards water. The alkali metals react with water to form hydroxide and dihydrogen. 2M2HO2M2OHA2++++ M equals an alkyl. It may be noted that although lithium has most negative E0 value, table 10.1, its reaction with water is less vigorous than that of sodium, which has the least negative E0 value among the alkali metals. This behavior is attributed to its small size and very high hydration. Of the group react explosively with water. They also react with proton donors such as alcohol, gaseous ammonia and alkenes. Reactivity towards dihydrogen. The alkali metals react with dihydrogen at about 673 K, lithium at 1073 K, to form hydrides. All the alkali metal hydrides are ions with high melting points. 2MH2MH2++, IV, reactivity towards halogens. The alkali metals readily react vigorously with halogens to form ionic halides, M plus X hyphen. However, lithium halides are somewhat covalent. It is because of the high polarization capability of the lithium ion. The distortion of electron cloud of the anion by the cation is called polarization. The Li plus ion has high tendency to distort electron cloud around the negative halide ion. Since anion with large size can't distort halides, lithium iodide is the most covalent in nature. V. Reducing nature. The metals are strong reducing agents. Lithium being the most and sodium the least powerful. Table 10.1. The standard electrode potential, E0, which measures power, represents the overall change. 2m S M G sublimation enthalpy M G M G ionization enthalpy M G HOM AC hydration enthalpy +++++ with the small size of its ion. Lithium has hyphen is +0.53. For Ag plus / Ag is +0.79. Na plus / NAFN 2.71 and for Li plus / Lis hyphen 4th of March arrange the following ionic species in decreasing order of reducing strength. I hyphen Ag order is Li greater than Na greater than I hyphen Ag greater than Cl hyphen. Alkali metals dissolve in liquid ammonia, giving deep blue solutions which are conducting in nature. M, ACHM, NH. E, NH, 3 times thrust plus the blue color of the solution is due to the ammoniated electron which absorbs energy in the visible region of light color to the solution. The solar param standings liberate hydrogen resulting in the formation of amide. MENH, 1, MNH a half H, G, M, thrust plus, where, M, denotes solution in ammonia. In concentrated solution, the blue changes to bronze color and becomes diamagnetic. 1st of October 7 uses lithium used to make useful alloys. For example, bearings for motor engines, with aluminum to make aircraft parts, and with magnesium tubes. It is used in thermonuclear reactions. Lithium is also used to make electrochemical cells. Sodium is used to make an A/Pb alloy needed to make Pb4 and Pm4. These organolead compounds were earlier used as anti-knock additives to petrol. Nowadays vehicles use lead-free petrol. Liquid sodium metal is used as a coolant in fast-breeder nuclear reactors. Potassium has THES- block elements 295, a vital role in biosystems. Potassium chloride is used as a fertilizer. Potassium hydroxide is used in the manufacture of soft soap. It is also used as an excellent absorbent of carbon dioxide. Calcium is used in devising photoelectric cells.